This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Hello, this is Matthew Farwell for Software Engineering Radio. Our topic today is property-based tests, and we're talking with Bill Venners. Bill is president of Artemer Incorporated, provider of Scala consulting, training, books and tools. He leads the open source projects for the Scala testing library and the Scalactic library for functional object-oriented programming. He is co-author with Martin Odersky and Lex Spoon of the book Programming in Scala, and he is a community representative on the Scala Center's advisory board. Bill, welcome to Software Engineering Radio.
Thank you.
So we've had several episodes in the past where we talk about testing, including episode 283, Alexander Tarlinder on developer testing, and episode 256, J Fields on working effectively with unit tests. Today we will be concentrating on property-based tests. So I think we need to start at the beginning and just define what is a property-based test.
A property-based test, it's a kind of test where you specify a higher level property of your code, something that it's supposed to obey, some specification of that behavior that doesn't really talk about how to test it. It just says what the thing is supposed to do. And then the testing tool will generate examples or data to test that property with, and it does that for you. So you end up specifying tests at a higher level, and it's a little more concise. And then the tool will fill in the data for you based on the types that are passed into the property.
What problem is this sort of testing trying to solve?
One thing is it helps make your tests more concise because there's usually less code, because when you write traditional tests, which are sometimes called example-based tests, you come up with example data. For example, if you have a function that increments an int and is supposed to return one more, you might come up with, well, let's try 0, let's try 1, let's try -1, let's try 42. That's probably a good one. And you come up with examples of data to pass into that thing, and then you check to make sure each time that it's what you expect when you pass 42 and you want to see 43. Whereas with a property, you would just say that what comes back should be one more than what goes in. And then the tool, the testing tool, the property-based testing tool, would come up with numbers to pass in, and it's going to try edge conditions like 0, -1, 1, max int, min int, and then just randomly kind of pick other numbers. So that makes it more concise. The other thing that it can help with is you may not think to try max int, and there's things you may not think of when you're in the heat of battle and you're filling in examples in your test. So I'll try this. I'll try 42. It's probably very well tested, but maybe 43 doesn't work, right? So it's usually edge conditions that you forget, and that's one of the first things these tools usually try.
So these tools, are they better at finding edge conditions, or do they just choose an edge just try them all?
Oh, well, it depends on the tool, and so what one tool, like I'm in the Scala community, so the main property-based testing tool for Scala is Scala Check. What it does is it tries edge conditions more often than non-edge conditions, and it has for each well-known type a set of edge conditions. So like for string, it's empty string. That's probably the only edge condition. For int, it's -1, 0, 1, min int, max int. Right. So for double, maybe it's not a number, maybe not, because often things aren't supposed to work with not a number. So things like that, it's just kind of selected for these basic types. And then when you define your own generators of data for your types, you can actually say, well, try these more often in Scala Check. And so you can come up with your sort of define your own edge conditions sort of by saying, I want you to test these values more often than randomly the others.
Okay, so do I require any special frameworks to use property-based tests? You were talking about Scala Check?
Yes. Scala Check is one tool. There's in the Scala community, there's others. And other languages usually have one. I think the original one I heard of was QuickCheck from Haskell, but usually you need a tool because something's got to generate the data. I mean, you could write that yourself, but it'd be kind of you're back to writing a lot of code. You'd end up writing the tool, so you might as well try to find one.
Okay, so what are some of the common use cases for property-based testing?
Well, some people just like it better, and they use it for testing. What I found was that there's a couple differences. Like one thing that I like the test-driven development vibe of you write a little test, make sure it fails, you write a bit of code to make it pass, and then you go back and write another test. And when you go back and forth like that, if you like that kind of development, you don't end up with a property. You end up with example-based tests. So that's one thing. What you could do is after you've done that, I suppose you could say, well, now that I've kind of got my thing working, I can step back and look at, well, what is the real high-level property of this, and refactor it to a property-based test if you wanted to. But we usually don't. We just leave the example-based test there and move on. But there are times when I think there are some use cases where an example-based test is easier. So one of them is if you have a reference implementation of something and you're creating a new implementation, you can write a simple property that says, well, for each of these functions on this thing I'm re-implementing, it needs to behave the same as that other one that I know about. That's real easy to write, and it's a lot easier than writing example-based tests. So that's one situation.
So you would use that, for instance, if you had a hash map implementation, you could make sure that your new super duper quick hash map implementation had exactly the same behavior as the old.
Right, the same output.
Okay,
but hopefully faster.
Yeah. Could you give an example of where properties-based testing found a real bug?
Okay, yes, if I can remember what it was. But for what I found was, so I like this idea conceptually, so I wrote a lot of them. And what I found is, either by the time I wrote them or, I don't recall ever finding, it's kind of like hard to write them first. So I tend to write example-based tests. I get things working, and then I would write some property-based tests just to sort of, feel more comfortable. And they would never fail for years because the code was working and it didn't break. But every time I would run those tests, every single one of those property-based tests would try 100 different ways to make it fail. That was the default in Scala check. And that takes time. So over the years, it was like, churning CPUs were using electricity, and, I was spending time, and these never found any bugs. So I was kind of wondering, geez, is this really worth it? And then, lo and behold, after many years, it did find one. And it was an edge condition. And I'm sorry, I don't remember what it was. But then I was like, okay, well, was that worth it? I think it was worth writing the property-based test. But what I did in Scala test, so I do Scala test, as you mentioned. Scala test integrates with Scala check. As in Scala test, I changed the default to try 10. Because where you want to try 100 is when you're first trying it out. But once the code is working, trying 10, that's not that many, but you don't just run your tests once. You run them over and over and over and over and over. And so over the course of a day, maybe you try 100, maybe you try 200, and that's enough. Because usually that thing doesn't fail. So that's one change I made was to try fewer by default.
Okay. Can you give some use cases where it wouldn't be appropriate to use property-based testing?
So one of the things I think property-based testing might be good for, and this is something I'm interested in exploring in the future, is they can take a lot of they can replace unit tests, like example-based unit tests to a good extent, I think. But integration tests where you're really having a lot of side effects, not sure that that fits as well as example-based tests where you really kind of have a BDD specification saying when I log in, when the user comes in and they log in, they do this, that kind of stuff I think fits. I just haven't seen the fit yet for property-based testing, how that intersects or works well with a large, scale integration tests where you're testing all these pieces together. You can do it, but usually those tests are slow, so you don't want to try something 100 times if it takes, 20 seconds each time, that kind of thing. I think it's sometimes hard to create a property too. Sometimes it's hard to say it. So
is what you're saying. It's difficult to find a property that actually applies to a test, to a system where you have lots of moving parts.
Well, you can. It's just, if I can't test 100 examples quickly, then why? I'm not going to test 100 examples, right? So I guess I would like to test edge conditions and integration tests, so that might be useful. But when one of the things Scala check does, for example, is its default was 100 because Haskell's quick check was 100. They try 100 things each time, and so if you try calling that increment function 100 times, that's like you can't tell it even happened. It's over like that. But if you are going to have to connect to a real web server that has to connect to a database each time, and it's going to be slower. So you could test things fewer numbers of times, but it's still I just didn't feel like the fit was there, and I really liked these specification style descriptions of integration tests that are really described around user experience, like when the user comes and does this and then that happens, then the user sees that. That's how you describe those tests.
So you're saying that for integration tests, for instance, it's more appropriate to use example-based testing than for
so I feel it. I have found that I just felt that was a better fit. I could write, you can always write a property where you wrote an example-based test. I think that's probably true. It's just, if it's with integration tests, especially because they take longer. Sometimes people have 2-hour-long integration tests, and you don't want to multiply that by 100. Right? It's just... So.
Okay. Could you give me some examples of a property that you could test with property-based testing?
I think, getting down, like if you write a function, or a member function, a method, just having something that specifies behavior of the method, like if you, nobody needs an increment function, but that would work. You could just say, basically you're going to specify. Let's find something more interesting than increment. Square root. Okay, so let's say you wanted to have a square root function that takes a double and returns a double, but instead of returning not a number, if it's a negative number, it returns, it throws an exception. So it's different than like on the Java platform you can get a square root, but if you pass in a negative, you get not a number. So that's all you're doing. I could specify the behavior of that. That's kind of an example of a method that has a reference implementation. The Java or the Scala math function that does square root is going to return. That's actually the answer I want, unless the input was negative. So I can just pretty easily write a property-based test that generates doubles. You say for all doubles, essentially. So long as the double is not negative, then calling my square root method should return the same double as calling math square root. So that's one property.
Okay. Could you do, for instance, a sorting algorithm as a property-based test?
Oh, yeah, that's a good one. So if I have a new sort algorithm, a sort method or a something you want to pass to a method that does sort, that takes like a comparator or something, or in Scala an ordering, and you want to test that, then you could write a property. Again, that would be a good one to do with reference implementation, because after it's sorted. That should be the same whether you're using your fancy fast algorithm that you're just designing or the existing, one of the existing ones. So you can call your method. You can let's say you want to sort lists or sequences. You could have it generate those, and it would generate an empty list. It would generate a list with 100 things in it. It'd generate a list with 99 things, and all random things. And then you pass that data into your sort method, and then you pass the same thing into the known reference implementation of sort, use a different algorithm, and you just say these two things should, the resulting sorted lists or arrays or whatever they are should be the same as each other at the end of it.
Okay. Does a property always have to be true or false, or can you do the equivalent of fuzzy matching? So it's mostly true.
Oh, fuzzy matching. Well, now that's something I haven't seen people do before. You could do that. Essentially, what you can do is ignore certain inputs. So, like if it generates that property, if it generates a negative number, we're going back to the square root one, if a negative double comes in, then you could say, well, ignore this one. So that's not fuzzy. That's just
cutting down the number of inputs to the
right.
to the domain of the function. Surely.
Yes. Yep. So that's not fuzzy. But as far as like getting it to just say 90% of the time this should be true, you'd have to write that yourself with ScalaCheck, as far as I know.
Okay. Do you think it would be useful?
Possibly. I've never needed that, but if you have something that doesn't need to be right all the time, like you could have something maybe that perhaps you could use that for if you have an SLA or something, and 95% of the time it needs to be below this value or something, you could maybe test that way. But
okay.
But usually when I think of a property, I tend to think of this is something that always has to be true. This is specified behavior, and that's what I express in it.
It certainly seems easier if it is either always true or always false.
Yeah.
If you look on the internet for examples of property-based testing, you get lots of examples covering things like associativity or size of sets or size of lists, but which seem to be relevant, seem to be useful, but aren't generally in the normal use case of the normal programmer, because normal programmers don't write sorting algorithms, don't write hash maps, Can you give some examples of let's call them algorithmic property-based tests?
Yeah, I guess you're talking about just examples are from like people who are designing collection libraries and things like that, which most people don't do.
Exactly.
Well, I don't know. You can just pretty much anything you're doing, you can use a property to express it, but it's often. The other thing that I guess maybe this part of what makes me feel funny about integration testing with property-based tests is that there's a lot of side effects going on. So where it's really a great fit is when I have a pure function that I'm testing, and I'm expressing its behavior. Its output is just it just depends on its input, and all I have to do is look at its output. So anytime you have a function like that, you could usually write a property, and it would be nice. When you have lots of side effects going on, you can still test it. You just have to test the side effects in the property, which is starting to feel a little funny. Okay.
So is what you're saying that a property-based test is nice to have if you have a function, if you have a pure function. But actually capturing a property for an integration test is hard because you have all of these side effects going on.
It's not that much. I don't think it's harder than writing an example-based test. It just feels weird to me because I feel like I'm not because of the side effects. It'll take longer. I feel like it's not as clean. What I have felt about property-based tests, when you look at the property, it's a function. It's a function like, for example, the one for square root would be a function that takes doubles and returns true or false, or returns an assertion. Like if it's in Scala tests, you usually use an assertion, not Boolean, but essentially there's an assertion of some kind in that as the result of that property. It's a function from the input type that you generate, that actually the tool generates, to a true or false, essentially. And I really feel like it's a specification. So one of the other things that I always thought was kind of intellectually nice, but it didn't take off in mainstream programming, was design by contract preconditions and postconditions that Bertrand Meyer put into Eiffel. And that essentially allowed you to write assertions about as long as my input is valid, then my output should be like this. So you could imagine, in Eiffel, if I was writing that square root method, I would have my precondition. He had a require clause that said, well, the double that's passed in has to be greater than or equal to 0. Right? That's your precondition. You write that in your property. And then the postcondition was the rest of the property, which would be, okay, now I've got a result. And he had a keyword result, so you could write assertions about the result. That needs to equal, and then I call my reference implementation. So it was kind of like a way to do property-based testing, except it was different in that these were run as assertions while the program was running. There was no separate tests that run against the public API of the production code. It's actually part of the production code, and then you turn it off when you really deploy it. So that didn't take off, and I don't like having post conditions running with the software. I think most people don't. They like those assertions to be in unit tests. We do leave on the precondition checks in the running software, but we don't. I mean, it's very rare that people in practice in the Java community, the Scala community, put post condition checks in their code. They tend to write unit tests off to the side and put their assertions there. But what I felt a property did is it does capture that specificationness of it. Like what you get with the Eiffel design by contract stuff is it's a nice formal contract. So like, you have a contract in Scala or Java doc. If you go look at the equals method on Java Lang object, it's not just documenting, it's actually a contract. It says anybody who implements this method has to do these things, promises to do these things. And so that's I don't call it informal, it's pretty clear in its English text, but it's a human language contract. Whereas then and those are important, but it's kind of nice that in Eiffel you had this formal expression of a contract in terms of code, and this is how you can specify the behavior of the function in code. So what I felt property-based testing does is it allows you to often, not in the production code sort of mixed in, but off to the side, you have this statement that says this is the behavior, this specifies formally the behavior of this function. So that's what I like about it, and that especially makes sense for pure functions, right? I mean, it just, you can usually specify a pure function with a property. When you have an impure function with a side effect, it's sometimes like I just can't think of a way to specify it with a property. And I can give you a specific example of that is iterator. Iterator's next and has next method. If you have an iterator in like the Java iterator, it's a mutable interface. It's supposed to, like, you use these. If you use next, it destroys something, right? And it's a one-shot. So how would you actually ever specify in a property formally that when I call this method, what happens? Because by the time you call it, you've destroyed it, and it's like you can't really do it. And so sometimes you can with mutable objects, like if it's a mutable collection, you can say when I mutate the collection by adding something, then when I look it up, it should be there. You can, but sometimes. But it's just like once you move away from pure functions, it sometimes gets hard even, or maybe impossible to really formally specify with code, with a property, what the contract is.
Okay. For coming back to the properties for a minute, could you explain what a reference implementation is, or a test oracle? I've heard it called. Yeah,
that's when you are re-implementing something that already exists in some extent. It could be an interface. I think the example you mentioned earlier was a new map implementation, and you can just grab a hash map and say, well, actually, all these methods should behave the same way. I just have a different performance profile. That's why I'm implementing this map different, a new one. But my property can just say, well, let's say there's a method size. You can generate data to put in the map. You can put it in the map, and then you call size. And you could call, the size method you could probably just count yourself, but you can also compare it with a reference implementation. Let's say it's a sorted set, a new sorted set. Then it could, whatever the order that the iterator generates elements out of the implementation that's from the standard library somewhere, should match the order of the elements that come out of your thing. And that's so the reference implementation is just something you have that you want to emulate exactly the behavior of.
Okay, so for instance, for a map, you could say if I put it in, then it should, and I try and do a get from the map, it should work, that sort of thing. And you could say, okay, so for the reference implementation for the map, you could say, okay, so I want to do a get, and it has exactly the same behavior as the get on my map.
Okay. Yeah, or something more complicated. Like we are redoing our website now, and we're replicating. Like it was written in Java. Actually, it's written in about 4 different architectures, starting in 1995. So it's survived a long time. And so the newest one we want to use is Play with Scala, and so we are moving the user sign in and email address changing, that kind of stuff, to Scala. So we have the new one, the new code, and we have the old code that, for the most part, we want it to be the same behavior. Right? So that happens now and then. It's when you have that situation where you have something that exists and something new, you can write a property-based test. That would be an integration test that says, okay, I call the website and sign in this way, and I get something back. I go over there, and I should get the same thing.
Or you add a user.
Yeah, if I add a user, they show up in some list or something.
Okay.
Right? Something. It's not that uncommon that you end up redoing something that there's an example of how it's supposed to behave, and you can just make a property to compare what I do to what that does.
Okay, another technique that I've heard of is there and back again.
Yes, that's another, I think, sweet spot for properties, which is a good one is some kind of serialization. Let's say you want to do Json serialization for a whole bunch of types. You can have a property that for any type T, it can serialize it to JSON and then deserialize it back, and then you compare the result with the original for equality, and you could say the property is those things should be equal, or they should have the same state, or something that is got to be true, so that you can compare the two. That's round trips.
Okay, so that round trip, that's a good way of putting it. That would be sort of any protocol, any serialization protocol, you could do it with a database as well, I suppose. If you save an object into the database and then read it back from the database, then it should be the same object.
Yes.
Okay, so now we've got these wonderful properties that we set up. How do we generate the data? How does the test framework generate the data for these properties?
Okay, so I don't know how they do this in Python, where there aren't static types to work off of, but in Haskell with quick check, what they did is and this worked in Scala also, essentially, let's say that going back to that square root function that I'm going to write that's going to throw an exception for a negative input. What the input to that function is double. So there is a generator of double. And when you write your property, you write it in terms of a function from double to, let's say, Boolean, right? And then in Scala test, for example, if you say for all, and then you just have a function that takes double, and then in the body of the function in Scala test, you would normally use an assertion, not a Boolean expression, but it's the same kind of thing where you're saying that it's something that should be true. Then when that compiles, the compiler can see that, well, the input type of that function is a double, so I'm going to look around for an implicit generator of double. Or in Haskell, it's a type class, gen of double. So it basically does it based on type. So if you need doubles, it'll generate doubles, and it says, okay, I know the edge conditions for double. If you need 2 ints and a double, then it needs 3 generators, right? So it basically looks at the input to the property function. It says, well, what are the types there? And then it's going to look around for a generator of those types. So if one of those is your type, right, something you invented, then there won't be a generator for it. So you're going to have to make one for that to get a property-based test to work. So you need to make let's say you make a new table class or something, then you're going to need a generator of tables, of your kind of tables, to get a property to work.
So just let me get this straight. We have a generator. There's inbuilt generators in Haskell and Scala check, which will generate a series of integers, for instance. Yep. And there's one for doubles. I assume there's one for strings as well.
Yep. Yes.
That sort of thing. Can we do more structured data? Can you expand a bit on the structured data?
So the way you usually make a new generator is use a for expression in Scala, which is you take, let's say you make a person case class in Scala. So now you have a new class that is a name that's a string and an age that's an int. I like to I just number my friends, so that's why I said name. So name is a string, age is an int, and so what I really need is I need a person generator. And what you can do is say for some age in, and then you have an int generator. Probably name in a string generator, you yield a person. And that's all you have to say.
It combines them?
Yeah, it combines them. And so now it's really concise usually to write a new generator in Scala, but you do have to do it, and it is work, right? So it's not like you don't have to write examples by hand. What you have to write instead is generators. There's a lot of them out of the box for basic types, so for those you kind of get for free. But as soon as you start having your own properties for your own types, you're going to have to write a generator. But you can usually compose it out of other generators that exist, and it's pretty simple. So for age, you might actually not want to say for age in int generator, it's posint or something like 0 or greater. You'd have a generator for just that, and there's a way to specify that. That's pretty concise also.
Can you limit the? You've said okay, it's a positive integer, but you probably want to limit the age to 150 or something. You don't want to max int as an age, or do you?
Who wouldn't want max int as an age? But we want it, but it probably you might want to put a maximum on there. So what you start with, you can say. Essentially, what Scala check tries to do, or these, there's not the only one. There's property-based testing tools. Try to do is make it, that there's a lot of generators on the shelf, or at least syntax for saying things like, I want an int between 0 and 150. And you can just write that very concisely. And then you just put that in your for expression, and that's what you'll get. You'll get ages from 0 to 150. And names, you might want to you might in your database have a maximum limit on the size of a name. Maybe that's 150 or something. So you can limit the number of characters in the string to a certain size, right? You might want to do that as well.
Okay. But actually, if you don't put the limit in, then you might discover something about your code that you didn't realize. So you might discover that the thing that you were expecting not to be null doesn't handle nulls correctly.
That's right. That's a good point. So what I like to do is I use, like, if you're not going to use a posint type for the age in your person class, then you should probably not just limit it to posints when you're in your generator, just for that reason.
Okay.
Yeah. So the type of your generator should match the type of your
target class.
Yeah, your target class. Except I was just thinking that the problem with that is then, like, going back to the double, like passing in a double, it's probably going to generate half negative numbers. And if you generate half negative numbers, these tools will often give up and they'll say, well, I just couldn't generate enough valid ones, right? So there you might actually have a generator of positive doubles and have a different property for making sure that when a negative is passed, it throws the appropriate exception.
Okay. And similarly, you wouldn't want to use an int generator for doubles.
Probably not, because you're missing a lot of numbers cases in between the whole numbers. Yeah.
Okay. Often in tests, you need data which is context dependent. So the data that you pass into a function depends on various different things. For instance, you were talking about a person. So if you had an address, then if that person lived in the USA, then they would have a zip code, and then a zip code has a set of boundaries. But if they lived in the UK, then they would have a postcode, so you'd have a different set of data. Can we do that? Can we handle that?
Yes. So what you would do there is maybe after you generate the age and the name, you generate a zip code, and then based on the zip code, you would generate a different kind of address, and then you would yield the big blob of data that you want.
Okay, that's good.
I mean, when I say generate, I mean, in your for expression, you would combine them in that order so that, like, the thing that depends on something else shows up after the thing that it's already been generated, or there's a value there, and it'll all.
Or you could, if you were generating a list or something like this, then you could generate a size of a list and then generate the number of items.
Yeah. Yep.
That sort of thing. Okay. So it strikes me that there's a problem here with combinatorial explosion. So if you have a particularly complex structured data, then you might not explore all of the different varieties of problems that you might have with that. How do we avoid that?
We don't. Unless it's Boolean, you're pretty much probably not going to explore the whole space. I mean, the int is 2 to the 32, right? So I don't know how long. If you do 100 at a shot, how many times is it going to take before you have explored all of them? So I have heard other people, actually me, it happened to me that where I caught something years later, and it was actually there for a long time. It just took a while to hit it. I'm sorry, I wish I could remember the exact use case, but people have told me that who have tried ScholarCheck, and they say, occasionally I'll not find it up front, but later it'll hit it. Usually it finds it pretty soon, because usually it's either the whole thing is broken or you forgot an edge condition, and it tries those more often. So, but every now and then it'll just, because the space is big and you don't explore the whole space, you may miss one, and it's not a proof. It's still a test, even though you're kind of writing it as like a specification. It's not really proving that it's not proving that the implementation obeys the specification or fulfills it. It's just testing that it does. So you may not, just because it even passes for a year, doesn't mean you don't still have a bug.
So these generators are generating data, and sometimes you would get tests where the tests would fail, but then the next time you run it, the tests pass because it's not using the same data set. How would you avoid that?
Okay. There's two things there. One is that the way you avoid that test failing in the future is fix the bug. But what...
you might not have context for the bug anymore.
Yeah, you might not remember what it was, right? So you want to reproduce it.
Yeah.
So that's something the tool needs to help with, and I don't know if this enhancement has gone into ScholarCheck yet, but in ScholarTest we have in our 3.2, which is probably going to be called 4.0 branch, we have some property-based testing that's native to ScholarTest, and there's a seed. Print out the output of a failed property-based test. It will also print out a seed, and the seed was what was used originally to flow through the random number generator and get the random data. And what we did is we made sure that was reproducible. Okay. So if you run your test again and you say dash big S or whatever we used and put in that seed, then you should get the exact same failure. So I think they they were wanting to put that into ScholarCheck also. It's something the tool needs to do, and I don't know yet if that's in there to reproduce it. And they had to change how random numbers were generated in ScholarCheck because they were using Java's random number generator, which really you couldn't really reproduce. I'm not sure. Anyway, that was an enhancement, right? So that's one thing. The other is that when you print out a test failure, you talk about what was the input to the function. So you might have a negative 42. Let's say negative 42 didn't work. We tell you that, it's negative 42. That's what caused the property to fail. So if somehow you couldn't get the test to fail again, you could just go in and pass negative 42 in by hand and see it. You should be able to. Okay,
so you could actually convert that into an example-based test.
Yes.
At that point, couldn't you?
And actually, that's not a bad thing to do. This is general practice in software development. Is you actually find a bug, you write a test that fails because of that bug before you fix it, and then you leave it there as like, well, let's have more clutter. That is, it's like if that bug ever shows up again, then this will actually do it. Yeah, there will be a test that fails, but maybe it's not worth keeping it around. But it's not. I tend to like to do that. I write that test and I leave it there.
Often when we're talking about property-based tests, we talk about shrinkers. Could you explain what a shrinker is?
Okay, a shrinker is something that I'm not sure they thought of it originally when they did Quick Check in Haskell, but essentially what these generators do by default is they try stuff all over the place. So strings, think about how you would generate strings. You don't just generate strings with A to Z, You actually just generate characters all over the Unicode character set, just for the heck of it. And so if you have something with a bunch of strings in it, and then what size should those strings be? They generate it. They don't want to go crazy and have them be, 64K long, but they'll go up to 100, and it gets quite noisy. Like some of these outputs saying, there could be 10 inputs to your function, and then they're just like huge, crazy looking things. So what these tools try to do is once it finds a failure, it tries to shrink that down to the smallest test case that causes the same failure, or causes a failure. They can't tell if it's the same one. So they'll take those strings that they know fail, and they'll try smaller ones progressively. And then, or the other way, you start small and go up, right? it tries to shrink them down. So it'll try, if it's an int, it's going to try 0. Well, maybe 0 worked there. If so, that's a simpler number. So what will happen in, say, ScalaCheck. ScalaCheck has a shrink that is, or a shrink that will kick in once it finds an error, and it'll work on that property and hit that property a whole bunch more times, trying to get it to fail with simpler input. And then it shows you the simplest input it could get the property to fail with in your output.
Okay, so maybe it starts at 0, it goes to 10, 20, 30, 40, 50, 60, 70, 80, 100. Oh, it fails at 100, so it goes, I'm going to try 90 again.
Right.
Try 95, 98, 99. Oh, it's 100.
Yeah.
It fails.
Right. I mean, it has some algorithm that's the shrinker algorithm, and you can redefine that. That's based on a type also. So you have a shrinker of int, a shrinker of double, shrinker of string.
Does it go back and try the original values that it tried last time, or?
Well, I think it assumes that's going to fail again. I'm not sure if it actually tries it again.
I guess that only works for one input, though, doesn't it?
No. The ones that failed last time, it knows. That's what the shrinker algorithm knows that, because that's what it uses to decide what to look at that's supposedly smaller. But I don't know that it would try it again, because it would just assume that it would continue to fail. I mean, we already have that one, so we don't need to run that again.
Okay. But if you have 2 parameters to a function, and you try 1 and 1, 2 and 2, and 2 and 2 fail, but 1 and 1 didn't, would it try 1 and 2, or 2 and 1, or would it go?
That's interesting, because there's 2 shrinkers there. The way that works in ScalaCheck, you don't have a shrinker of 2 things. You have 2 shrinkers of int. So it depends on how ScalaCheck works. So when we did our shrinking, we did it differently than ScalaCheck. And I can't remember which one. One of them started big and went small, and the other one started small and went big. But it's really like, a lot of times you're just kind of guessing. It's like, well, I don't know. I have no idea how to make this smaller. So I'm just going to try this and this and this. And like for an int, we'll try numbers down from 0 to 10 just to see. And then we start going larger hops, kind of like you described.
Okay.
And then, if it's getting big, like if it's 100, that was what failed. And we got to, 50 and it didn't fail. We just say 100, I think. But that's a shrinker algorithm, and you can actually redefine that yourself. You can write a shrinker of your type or shrinker of int and use that instead if you want to.
Okay, so how would you go about writing a shrinker of a structured type, say for the person, dress?
You are given, like let's say a person, you're given the person who failed. Poor guy. This person failed. So now you have their age and their name. Let's say that's what's in there. So what you might do in your shrinker of person is take a shrinker of int and shrinker of string, maybe, and just reuse those. But essentially what you get is you get that initial person, and you have to produce, in ScalaCheck it's a stream of people, and it ends at some point. So you're just going to say, okay, try this one, try this one, try this one, try this one, and that's all you do. So you write the tool, you're given the one that failed, and you just produce a stream of, finite stream of other things to consider, which are smaller in some way, simpler in some way, and that's it.
Okay, so in that case, you could try, as I've just said, you could try reducing both of them at the same time, or just reducing one of them, or reducing the other.
Right. And you're kind of guessing. But it actually works sometimes. I think you'll see crazy failures, and then you'll see simpler ones, and it'll say, I shrank 3 times, and shrinking does work, and it does make the output a little nicer sometimes. When it can, I guess
it's quite good at working on lists and collections and maps and sets.
And ints. I mean, a lot of times, like I was saying, that once you get the code working, these tests don't tend to fail for years. So this is usually more when the bug, you're just writing the thing and it doesn't work yet. So really quickly it finds a bug, but with crazy data. Well, it turns out that bug is there on simple data. That's why I think that's when shrinking actually helps, is when you're first writing something and the thing just doesn't work. And ScalaCheck found some crazy input that failed, and then it looked and it's like, oh, it actually doesn't fail. It fails for empty string too,
Okay, so for instance, size of a list or something like this, it always returns 0 in your code. That's the bug. So it tries it with a 0 length list. That works. It tries it with a list of 1,000 items. That doesn't work.
And it shrinks it down to 1, a list with 1 item. And that's much
Exactly.
prettier in the output. Yep,
Yeah.
that's a great example.
And much easier to understand as well. So moving on to other aspects about property-based tests. So moving on to other aspects, would you recommend a mix of property-based tests and example-based tests? And if so, which one would you start with?
Okay, so yes, I would recommend a mix. So
You said that
I'm evolving. So what I do like to write, a test first, and then a lot of times I'll do that, and then I end up with example-based tests, and I just leave them there. But what I want to do in Scala test is formalize this notion of a specification outside, kind of like a Bertrand-Meyer contract, but expressed as a property separate from the thing, which I think for pure functions is really nice. So I want to try to make that easier to, in Scala test, make that easier to do. So we'll see. But for integration tests, as I said before, I literally think of that as a user, or from outside the system, using the system from the outside. You write the specification of behavior that way, and it's really just something even the marketing people can understand. When you come in from the outside, this is what happens, this is what's supposed to happen, and I think that really clicks because everybody can understand it, and it's less of a appropriate for property-based testing. But unit tests, except for the nice write a test, write the code, write the test, write the code rhythm, I think unit tests could be more concise and better if you could actually just specify these contracts, these formal contracts, or specify the behavior with a property of each pure function at least.
Okay. Would you, are there any techniques for dealing with state?
Oh, yes. The Scala Check there's a Scala Check book we published that has a chapter on state, and he's given a talk. I saw Ricard, the guy that did Scala Check originally was Ricard Nilsson, and he gave a talk. What he suggests there is you make you generate almost like a script, so you can make a hierarchy of objects that are operations, and sometimes the operation has some data associated with it, like create user would have a username or something. So you'd make a create user class that takes a string name, right? Some of them could just be objects. They're just not no ops, but like go or stop or something, right? So you define this set of sort of an API that describes actions, and then what you generate is little scripts, little sequences of those objects that then the property can fire at the object and then look at, it needs to know what's supposed to happen, but I guess you might need to generate what the result it should be. But that's how you can do it, is like when I make these, and it's randomly generated what the actions are that you fire against the mutable thing. And that's nice because you're really trying all different kinds of combinations of actions. And then you just check the after all that happens, is this state of this mutable thing in what I expect it to be.
Okay. So you're kind of modeling it as a pure function, almost, because you're doing all of these operations, you're firing all of these operations, and then you're seeing what the result is. But the result is just the mutable state of the object.
Yeah, I mean, you could basically it has to be predictable, otherwise you wouldn't know what would happen, what to check for at the end. So it couldn't be like, okay, have 27 threads fire things at this. I have no idea what's going to happen at the end, right? Yeah. It's one thread does just these things, and at the end I know what it is. So what it means, I think, is that it could be rewritten. Like if that thing wasn't mutable and it was immutable, you could rewrite that as a series of, instead of 20 mutations, 20 transformations, and then you have the output. But in this case, it's instead of transforming things 20 times and throwing away 19 intermediate steps to garbage collection, you just mutate it in place. But you start with something you mutate it in place is the only thing doing the mutation, and then it's going to be, you can expect it should be in this state, and you can test it that way.
Do we need any specific language features to do property-based testing? Do we need reflection? Do we need a functional language? Do we need immutability?
I think it's, like I said, I don't know how they do it in Python. They do it. There is one, But I don't know how they do generators. I guess they just make a generator and pass it in by hand. I guess that's how you do it in Python. So that's fine. So I don't think so. I think the answer is technically no, though what I think is it's really a nice use case for static types, because I can just write a function that says it takes these 3 static types, and as long as there's an implicit generator, or a generator type class, depending on what your language is, it just generates data for you and tests your...
Can we use property-based testing on a more complex system, or should we stick to small algorithm-based modules? So that could be, could we start with small algorithm-based modules, or should we start with a complex system?
I'd start small, because I actually haven't done big ones. I know people who have, and so I just definitely it's a good fit for pure functions, and you're specifying them from the outside. That's like a unit test. As far as and no matter how complex it is, if it's pure, you can do that. But if it's like a massive enterprise system that's running, a company, then you could find things to test. I mean, there may be secure. I don't know. You could try. There's use cases, where you want to generate a lot of things, like maybe penetration testing or something might just be useful, where you try all kinds of stuff, possibly with smart generation, and let it just hammer away at it. I mean, that's possible. But I do think the sweet spot is kind of as an alternative way to do unit testing for testing things in the small. That's the sweet spot.
Continuing on from that, can we do non-functional testing, such as performance testing, using the same techniques?
Actually, I haven't done that before either with property-based test. But that's where you would want. That's what actually I thought of when you asked me about fuzzy, is that. I'm trying to remember, I recently, just like last year, we had a client where we were doing performance testing, and I'm trying to remember how we generated we definitely tried a bunch of things. How did we generate that? I don't think we used a property-based test. We just generated it. I mean, there's other tools for that. Like, there's one written in Scala called, it's like Gatling, that's one. I mean, that's one tool. And there's tools just for performance testing that you might look at, but you could, I mean, what you can do with a property and a generator and a property-based testing tool is just hammer away at something. And if what you're interested in is that it meets an SLA, and maybe you could use it for that. Okay, so you could use, for instance, the generator as a basis for the Gatling, for the thing to send. For like hammering away at something. And what I did is, I'm actually remembering now, we had to generate, you generate customer IDs. Customer requests or create customer, these kinds of things. So we had to generate them somehow. We used the same random number generator that we were using in the properties. But I don't think it was like a property-based test. We just used pieces of it to do generation. But it wasn't like a property-based test. We just probably, it's been not that long, but I can't remember where we put the data. But we had these beautiful graphs saying, well, here's our performance. But it's different. It's a little bit different than what you do with property-based testing. How does property-based testing impact a team's development process? That is a good question, because when Kent Beck years ago went around and talked about test-driven development and write a test first, then you write the code, and he said about a third of the people, or maybe it was Eric Gama, and he wrote JUnit originally together, but they were saying that about a third of the people are, what do they call it, test infected, where they get oh my God, this is the best way to do things, and they do it. Another third of the people were like, I think it's a good idea, but I'm lazy or I'm busy or whatever, so they kind of do it when they're not as faithful at doing TDD. And then another third is saying, this is ridiculous, I don't want to do this. And so that sort of for the 1/3 who really likes TDD, you don't actually get the same feeling. It's not the same, because I think what are the things you get about that? I mean, you're running example-based tests, but it's not just that. It's driving your thought process. You're saying, okay, well, what's the first little piece of functionality that I could do? What's the smallest one? Oh, I can do that. So let me write that down in a string. That's my test name. And then I write a test that does it, and it's just this little thing. Then I go implement that, and you just go back and forth one at a time. So that you kind of don't get with property, because what you do is you step back and say, okay, what is the behavior of my function? The whole thing. And you could write that first, but it's just not quite the same process. So I think that's For that 1/3 who loves it, maybe they would prefer to stick with example-based tests to develop. But for the other third, who knows? Maybe they like this better, or maybe they just don't like testing at all. It's possible.
Yeah. Does it affect how you think about your code?
Maybe. I mean, what I had was a mix, right? In my practice, I inserted property-based tests just because I thought, well, okay, I'll stick this one there too. It'd be a good test. I don't think I was thinking in terms of specification so much. And I feel like that's why I was saying I want to add something to Scala test to make that feel more like I'm actually specifying the behavior of the function with a property and kind of make that more obvious or something. Because right now what I had, just like I stick a property-based test in the middle of my example-based tests. And you can do that in Scala test quite easily, but then it's just like another test. It's a more thorough test and it takes longer. So it's, I kind of feel like it'd be nice that Bertrand Meyer had something with his design by contract stuff where you specify it next to the code. The other thing I felt with testing is that, your tests just grow over time and they're kind of all over the place, and it's just not an obvious mapping between what this tests and what the code is. Whereas when you have a function, if you put right there this formal description of how it's supposed to behave, like in the same file, but not running it the way Eiffel did. But like somehow running it as a test, that would at least associate it some way where it's like mapped, it's obvious that this is the specification of that. Maybe it's not in the same file, but the tool matches them up or something. I think that would be an improvement, because I sort of feel like these days we write the code and we write the test over there and they're just so disconnected sort of that, you don't have that feeling of I'm formally defining how this is supposed to behave, and then by the way, I get this test that runs automatically that tries to find examples that will cause it to fail, and it's just that's all I write. I just write this formal specification, which is a lot less code, I think, than normal example-based tests. So I think that, like, for future directions, I'm going to try to explore that with some enhancements to Scala test to see if we can get to a place where unit testing kind of comes for free when you specify formally the behavior of a function.
Okay. So I think we're drawing to a close. Is there anything else that I should have asked you?
Well, no, I think we've pretty much covered that. I think that's the state of it currently. The state of testing is property-based testing. I mean, it's not very popular. You don't see a lot of people using it. People who come from the Haskell worldview love it, and they use it a lot. And they try to, explain it to other people, but they tend not to use it that much. I don't know why. But most people who are doing testing do example-based testing these days still.
Still?
Yep.
One test is better than no tests.
Well, example tests are better than no tests, I guess. Yeah.
Yes. Okay. Well, thank you so very much for joining us.
Well, thank you for inviting me.
This is Matthew Farwell for Software Engineering Radio.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.